Okay, hey everybody, this is Mr. Bells again. This video is 2-5 continued. This is what happens when we don't have any technology, and it's a long process, but I think it's really good for your brain and for your challenge and stuff like that. So we're going to try and do it together, kind of walk you through the steps. How do we find all the zeros to a polynomial? We got no technology. Big scary looking one first. So if you guys could go ahead and copy that one down just like that. X to the 4th, 7x cubed plus 11x squared plus 7x plus 10. Now, of course, I went through and I made these kind of make sense. So it's not like this should be completely gone. But we're going to see, again, no calculator. So I can't even graph it to find any of the real ones. So we have to remember that if there are real zeros or rational zeros, they have to be factors of 10. So I need to check plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Knowing that, remember, it's all the factors of this divided by the leading coefficient factors, but since that's 1, that makes it pretty easy. So we're going to try one. Just go. And that's what we do, is we try it. So I'm going to try -5, see if that one works. So 1, 7, 11, 7, 10, and I do my synthetic division. I bring down a 1, -5, 2, -10, 1, -5, 2, -10. Holy crap, it actually worked. So I know that it did work. You're not going to get that lucky all the time. But remember, there could be 4 real ones here. I did it, and now I have a cubic equation here, right? X cubed plus 2x squared plus x plus 2. And I'm going to see if I can work that one out. So here's the deal, though. We knew that those were all the factors from now. I'm going to rewrite them again. Now all I have to check is plus or minus 1 and plus or minus 2, because this is my new end term. So I was able to, by checking -5, and again, I didn't find upper bound or lower bound with that because I actually found a 0, I was able to get rid of all of those. Okay, one more time. Because I went from a degree 4 to a degree 3, and this new thing means the zeros can only be factors of this. Okay? So I'm going to go ahead and try -1. Let's try -1, see if that works here. So I'll bring the 1 down. 1 times -1 is -1. 1, -1, 0, 0, 2. Awesome. Okay, so this says this -1 didn't work, wasn't a 0. And then I'm going to say, hey, is this a lower bound? So in order to be a lower bound, just a little reminder on that, lower bound, these have to be alternating non-positive, non-negative numbers, or alternating non-negative, non-positive numbers. That one right there, in fact, these are all non-negative, so they can't alternate between non-negative and non-positive. So that means this is not a lower bound, and if that's not a lower bound, then it's my belief that -2 probably works. So we can scratch that out, and we'll retry again with -2. Here we go. Well, I don't know. 1 times -2 is -2. 2 and -2 is 0. 0, 1, -2. Oh, look at that. Remainder is 0. So that worked. Not only did that work, but now since we went from a x to the 4th, we went to an x cubed. Now we're at an x squared. So what do we have? We have x squared plus 1 left over. Okay? So again, we were trying to find all zeros and factors. So I found 2 of the zeros. Let me write them over here so we have some organization. I have a 0 that's a -5. That one worked from this. I have a 0 that's a -2. That one worked from this. Again, both of them gave me remainders of zeros within the division. And now I have a polynomial. And this one, again, pretty simple to be able to solve, right? Because there's no linear term, I can just move that over. So I subtract 1. And I get x squared equals -1. Root it, and I get x equals plus or minus I. So I and negative I. Those are my four factors, or 4 zeros. My factors then are x plus 5 and x plus 2, right? And my irreducible quadratic factor is x squared plus 1. Now granted, you could have written them like this too. That'll be the last step that I do. Like that, all four of those. So, one more time, if I multiply all four of these things together, I'm going to get that. If I multiply all four of those things together, I'm going to get that, because these two things are the same. Okay, so that wasn't too hard. This one, on the other hand, this one looks a little scary. So it could be at this point that you might have 2 or 3 pieces of paper going. We typically do these things in some groups. So we're going to try it. We're going to see how we do here. So if you could, 3x to the 5th minus 6x to the 4th minus 15x cubed minus 18x squared minus 72x. This looks scary. So step number 1. Step number 1, what should I do? What should I do? I feel I saw it. Look, do you guys see it? There's an x on all 5 of those terms. I can pull an x out, which means if I can pull an x out, I know that one of my zeros has to be 0. And then some of you are like, oh, Mr. Bills, look a little closer. Look a little closer, and you'll see. I can actually pull a 3 out, so I don't even have to worry about this leading coefficient on this one right here, because I'm going to be able to remove that. Okay, so let's go ahead and pull that out. So when I pull a 3x out of this, this is actually what's going to be left. X to the 4th, right, minus 2x cubed minus 5x squared minus 6x, and is that 24? Minus 24. Okay, so I can kind of just remove that one. I'll go ahead and list it over here. Factors. So 3x happens to be one of my factors, and a 0 happens to be one from this. But now I'm going to work with this thing right here, which means I have to look at possibilities. What are my possibilities? Plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Crap, that's a lot of them. That's a lot of them, but that's what happens when you got a 24 there. Okay, so you just start with something. So I'm going to go ahead and start with 6. You guys start with 6, negative 6. Let's go ahead and start with positive 6. So let's start with positive 6. So 1, negative 2, negative 5, negative 6, negative 24. Bring the 1 down. 1 times 6 is 6. That's 4. That's 24. That's 19. That's 60. Can we just say big? That's positive. That's positive. So what did that just tell me? What did that just tell me? All of those are non-negative numbers, which means 6 is an upper bound. So if we had to look at all of these being positives and all of these being negatives, right? Then not only did 6 not work, but 8 won't, 12 won't, and 24 won't, because that's an upper bound. Remember from our stuff from a few lessons ago. Okay, so let's go ahead and try 2. I don't know, let's try 2. And this is what happens. You just try stuff and see if it works. 1, negative 2, negative 5, negative 6, negative 24. Bring it down. 1 times 2 is 2. That's a 0. 2 times 0 is 0. That's a negative 5. 2 times negative 5 is negative 10. Negative 10 and negative 16, or negative 6 is negative 16. And 2 times negative 16 is negative 32, and that's negative 56. So question, are all of these ones non-negative? The answer is no. So that means that 2 is not an upper bound, which means either 3 or 4 is going to work. But guess what? We give it a shot and we try. So let's try 3, 1, -2, -5, -6, -24. You should be getting good with your math right now, right? Bring the 1 down. 1 of 3 is 3. That's 1. That's 3. That's -2. 3 times -2 is -6. That's -12. 3 times -12 is -36. That's -60. 3 is not it. So, gosh, I hope 4 is. 4. Trying 4. 1, -2, -5, -6, -24. 1 for 2, 8, 3, 12, 6. Hallelujah. Remainder of 0. So 4 worked. So here we go. 4 works. X minus 4 is a factor. And now I have a smaller thing. That smaller thing also tells me, right? Here we go. 4 worked, yes. That now my factors are only 1, 2, 3, and 6. So my -24, -12, -8. 4 doesn't go in. -4. I don't have to check any of those. Isn't that nice? Because I just reduced my quadratic. Now I have this. But I got to try with this. So I don't know. Let's try -2. Right? These are all negatives. So let's try -2 with my new thing. 1, -2, 0, 0, 3, -6. Yes, remainder 0. Woohoo! That's rockstar awesome, yes? So not only that, -2 worked. -2 worked. So put it up here. That's a 0, and x plus 2 is a factor. But you can see now I'm down to a quadratic. And at this point right here, I have x squared plus 3, which I know. If I want to know the zeros to that one, it's going to be x squared equals -3, right? Just like that. And poof. Square root both sides, right? X equals plus or minus I root 3. So I root 3 and negative I root 3, and my other factor I can leave in that quadratic form, x squared plus 3. Is that good? Okay, so hopefully you saw that there's going to be times, right? This was frustration times, like, oh, I didn't get it. But even though I didn't get it to work, I learned stuff, right? I learned stuff. And then once I got the first one to work, then the other ones started to happen a little bit easier. Okay? Now, again, in class, I'll show you the one where what happens if we get down to this, and this has got a linear term in it, which 100% it could happen. Remember, we'll have to use quadratic formula completing square. That's the last section of the 2.5 video. So what do I have for us for my final thing of this 2.5? What happens when we build something if we know that these are the zeros, okay? And now I have imaginary zeros, and I have a 0, that's a 0, and I have irrational numbers that are zeros. Like, holy cow. Can I find a polynomial, right, with zeros and write it in standard form? And this is going to be a lot of algebra. Trust me on this. This is going to be a lot of algebra. So the first thing I'm going to do is I'm going to try and write down what I know is true. So because I can find a polynomial if I can list all the factors and multiply all those factors together, right? So if this is a 0, then I know x has to be a factor. If this is a 0, then I know x plus 1 is a factor, right? If this is a 0, then x minus root 3 is a factor. And if this is a 0, then x plus root 3 is a factor, yes? And which means if I multiply these two things together, I'm going to get x squared plus 3. So now I've got 3 factors, but I'm already up to degree 4. And this is the one that I kind of wanted to make sure that you guys were paying attention to. Remember that you can never have a singular imaginary factor for these polynomials, that if negative 2i is there, then also positive 2i has to be in there, which means if x plus 2i is, then x minus 2i is, which means this came from x squared plus 4. Hold up, sorry. I apologize. That's a minus. If it was a plus, that would give you imaginary solutions, and those are actually real. They're just irrational. Let me rewrite these again. X squared minus 3, because a negative times a positive is a negative. Ooh, almost did that. This one over here, since they're imaginaries, I have to have this. So x squared plus 4. And you could check it. If you plug 2i into here, you'd get negative 4. That would give you a 0. You plug positive 2i and you get the same thing. Okay, so I have to multiply all these things together. This is big. X squared plus 4. X plus 1 and x. Okay, so I'm going to do these things first and these things second, and then multiply those two things together. Again, big algebra here. So x squared times x squared is x to the 4th. Negative 3x squared plus 4x squared is plus x squared. Negative 3 times 4 is negative 12. Here, x squared plus x, right? X times x is x squared, x times 1 is x. So now I got to multiply these together. So x squared times x to the 4th is x to the 6th. X squared times x squared is x to the 4th. I'm going to move it over a little bit so I can leave my x to the 5th term in there if I have one, if I need one. X squared times negative 12 is negative 12x squared. X times x to the 4th is x to the 5th. X times x squared is x cubed. X times negative 12 is negative 12x. Polynomial x to the 6th plus x to the 5th plus x to the 4th plus x cubed minus 12x squared minus 12x. Big ol' honkin' thing. This equals that. And if I am right, if I did all this algebra right, which I believe I did because I did it kind of fast, but I believe in it. If I graph this now, right, because I did all this without the graph, if I graph this, all of those things should be true. Pull it out. Let's see your calculators. Here we go. I'm going to bump this down a little bit here. Y equals, clear. This is huge. X raised to the 6th plus x raised to the 5th plus x raised to the 4th plus x raised to the 3rd. Oh crud, I missed it. X raised to the 4th plus x raised to the 3rd minus 12x squared minus 12x. Now remember what we said before with this stuff, if you've watched some of the other videos, this is a degree 6 polynomial. That's a big honking thing, right? The older TI calculators might not be able to handle this. The newer one, I don't know if I'll see everything, but I'll give it a shot. Look at that. It looks like those are 4 real places, yes? Those are 4 real places. So remember, I'm going to come back to this again. Remember, bigger picture here. I know that negative 1 and 0 should be real ones, right? I know that those are also real, but the square root of 3 and the negative square root of 3 are not whole numbers. So when I go to the table, that's going to be a little bit tougher. And then I know that my last ones are imaginaries. Okay? Let's see. Table setup started at negative 5. Let's look. Look at that. Negative 1 and 0. Those are 2 of my zeros. Check. Check. Square root of 3. I actually can do this. Watch. I'm going to start it off at the negative square root of 3. And you can see, look, I get a 0. And I'm going to start it at the positive square root of 3. So I'll just delete that. That's still square root of 3. And I get a 0. So check, Check. Now, how would I know that negative 2i and 2i actually work? Well, I could go back through here and do synthetic division with negative 1, with 0, with root 3, with negative root 3, and I would be left with a polynomial, and that polynomial would be x squared plus 4. Okay? So hopefully that was beneficial. This is section 2-5, completed form. Again, we're going to practice some stuff in class. Hopefully we'll do some partner things, some group things, some whole group things, and see how well you guys do. Awesome. We'll talk to you later. Peace out.